Alrighty, this is Algebra 2, Semester 1, Unit 4 Study Guide. This is Part 2, just the tail end of it. These are all story problems from here on out. I'd like you to do the story problems. They should always make sense. We're given the pathway of a football. You can see out here it's a negative, so it's going to be a maximum. It says the height in feet of a football X seconds after it is kicked from the ground. So this is seconds, because it just said X. And y must be height. So they really want us to go ahead and graph this, and it shouldn't be a problem to do that. It is in standard form, so you could just go negative b. We went ahead and we labeled the axis, so we've done that. What do the X-intercepts represent? Well, we'll see it here in just a minute. Let's go ahead and do negative b over 2a, that'll find our axis of symmetry. Negative b is negative 40 over 2 times negative 16. So that's going to be a negative 40 over a negative 32. That'll become positives. 8 goes into both, so 8 goes in there 5 times. 8 goes in there 4 times. Wow, so I think we could almost make this into quarter seconds. So 1, 2, 3, 4. Mark that as 1 second. 1, 2, 3, 4. Mark that as 2 seconds. And I only made that assumption just knowing that we were coming out with a fraction. I didn't want to be estimating down here on 1 square, so we're hoping that it fits. 5/4 would be 1 1/4. So we put our axis of symmetry right along that line. Okay, it's 5/4. What is a reasonable domain of the function? Explain. Well, we'll get there. And what is the maximum of the function? Okay, so in order to get the vertex, we have to plug in that x value. Now, you may be more comfortable with a decimal. It would be 1.25. 5/4 squared, I just go ahead and leave it as a fraction. 5/4 squared plus 40 times 5/4. Well, we know 5 squared is 25. 4 squared is 16. Multiplied by negative 16, that's going to cancel. We get a negative 25. The 4 and the 40 will cancel and leave a 10 up here. So it's a negative 25 and a plus 50. That sounds familiar to something I told you. Always opposites. This one's always half the size of that one, and they're opposites. So our answer will be 25 for our y value on how many feet in the air it goes. That's our maximum. So it means that the ball travels 25 feet. Now our other thing, up. Maybe we should put max. Now the other thing is we know it goes here, so let's count these real quick. 5, 10, 15, 20, 25. That might be okay to do it that way. Now where do we know that the ball starts at? On the ground. It's being kicked. From the ground, it says. And then it lands, well, if this is 5/4, we'd go 5/4 more. So it lands clear over here. And we have a maximum. Now, up here it asks, what is reasonable domain for the function? This is one of the few that I have you do where you don't have all real numbers, because that ball doesn't go forever down here, does it? This is a real graph. It would start at the ground, it would end at the ground. So a reasonable function for domain would be that domain is from 0 over here to, there's 2 and 1/4, 2 and 2/4, so 2 1/2. And it can be equal to that because it's landing on the ground there. Now the last thing is, it says what do the x-intercepts represent? Where's the ball at? It's on the ground. Ball at height 0. Or you could say ball on the ground. Okay. Find the approximate solutions. We did some of these in class. And I really want you comfortable with them for your test. So we have, here we do it algebraically, x plus 1 squared plus 2 equals 5. Draw our line down, subtract 2 from each side. Gets rid of that. X plus 1 squared equals 3. Square root each side, so we have square root x plus 1 squared. That cancels the square and the square root. And square root this side plus or minus square root 3. Now we subtract 1 from each side. X equals negative 1 plus or minus square root 3. Okay? So it's not going to be a whole number. We do know that it's 1 plus or minus square root 3. Square root 3 is closest to square root 4, so that would be 2. So it's going to be close to, a little bit under, negative 1 plus 2, and negative 1 minus 2. So it's going to be a little bit under being out to negative 3. It's going to be a little bit closer than being out to positive 1. Now let's go over and graph it. It's in HK format. My vertex is negative 1, positive 2. So I go to the left one, up 2, and it's a minimum. So I just draw my parent function. Okay, and now remember I draw this as a straight line on this graph. So I go up to 5, 1, 2, 3, 4, 5. I draw in that straight line. Now the solutions that I came up with here should match my intersections here. I said roughly it would be just a little bit under being out to negative 3 and a little bit under being out to 1, so that looks correct. Okay, find the exact solutions by using square roots. We did, right up there. Be very comfortable with this. Now remember, you could have, like we have here with 2 solutions, or we could just modify this. We could modify it and move this line down to the 2. If we made it x plus 1 squared plus 2, and we move that line down to 2, we'd have one solution, wouldn't we? One solution. Or if we moved it down to 0, we'd have no solutions. X plus 1 squared plus 2 equals no solutions. Think about that. This one, we did this on the final. I don't know that you need it now, but we'll go ahead and we'll do it now. We put it in standard form. Ax squared plus bx plus c equals 0. And now we plug in our x and our y value. So we would say this would be a negative 5 squared plus b times 5 plus c equals 0. I'll tell you what, ask me to show you this one in class because it looks like my battery's going dead. Ask me to show you this one in class, that way I'll know that you watched this video. Okay? The bottom one, the football being kicked into there, we've already done one of those in warm-ups, so go to your warm-ups, your in-class notes and get those, or you can do one off of the video notes. There's one in that section. Okay, you have a good night. Good luck on this test. Remember, the test will not look like this. You're going to be asked to do a lot more thinking about what it means, like what we've done in class. Thank you.